Okay, like I said, students find this difficult. I think it's because everything's really, really similar to each other. Like question 9 was really hard on the quiz yesterday because I think it was similar to other things. So now this is similar triangles. What do we know about similar triangles? What are the... They're similar. What does that mean, Tristan? They have 3 sides in triangles. Yes, all triangles have 3 sides. But when I say 2 things are similar in math,
their angles are equal.
Their angles are equivalent. So whatever angles are in the first triangle are in the second triangle. And there's one more property. Sides are in proportion. So if this side is double the length of the other side, all the other 2 sides of the triangle also have to be double. So similarity has some key points to it. And you would have learned this in grade 9. This is where you would have got this information. So, let me do that. So the word similar, so they have equal angles, no, equivalent angles. Equivalent angles in the 2 triangles, and their sides are proportionate. So if I give you a triangle, do this little triangle, and it has side lengths 2, 2, and 3, and this angle, say that one's 90. What would it be? 2, 2?
And below,
what would it be? It'd be root 4? No, it'd be root 8. Okay, let's do our math correctly. My answer, let's put it as root 8. It was all fine and dandy until I put that right angle in there. And then that's what happened. This is going to be root 8. And then this would be 60. Right? So if that's my original triangle, and I say you have a similar triangle, and it's bigger, these angles are all the exact same. As soon as you see these angles being the exact same, it becomes a similar triangle. If I say this one's 4, what do we times 2 by to get it to 4? 2. So that means every side increases by 2. So that would mean that this side is also 4, and this would be 2 root 8. I could simplify root 8, but we don't have time for that. So just remember that they have equivalent angles, and their sides increase by the same rate. It's called a scale factor, and we did that in grade 9, so if you don't remember it, not a huge shock, that was a while ago. Okay, with knowing that, point P theta, lies on the intersection of the unit circle and a line joining the origin to the point 4, 3. Find the coordinates of P theta. That's a lot. What do we know about the unit circle? Radius of 1. Okay, that's what we know. So we also know that we have a point out here at 4 and 3. Let me go bigger than that. Okay, my point 4, 3 is out there. Everybody agreed? It shouldn't be inside the unit circle because this would have a distance 1. So this should definitely be outside of the unit circle. Right? Because this point here would be 1, 0. It has a height of 0, 1, right? Like those are your key points on your unit circle. So this point has to live outside of it. So it says point P theta lies on the intersection of the unit circle and the line joining to this point to the origin. So this point to the origin is here. Here is P theta. Okay, so this, we want to find the coordinates of this point. And yes, you do have enough information to do it because you just have similar triangles right now. I'm going to draw my red triangle. What do we know? I know one thing about this thing. I know two things. There's a 90-degree angle. Okay, sorry to steal your thunder. Do you know the other thing, Dion? You do. Steve does, because Steve said it. Somebody said it. Hypotenuse of 1. Because it's a unit circle, right? Everybody good with that? Okay, now we have this blue triangle. And we know something about the blue triangle. What do we know? Actually, we know 3 things about the blue triangle. You know the side. It's good job. So proud of you guys. You're not wrong. You are not wrong. I just erased that 0, 1 just because I'm going to erase some more coordinates there. Okay, so in the blue triangle, what do I know? Yeah.
5.
How?
4 squared, 16.
Okay, so back the bus up and tell me the 2 things you know prior to 5.
Okay. Well, x value is 4, y value.
So we know that the base of this triangle is 4, and we know the height of this triangle is 3. Right? Just from that coordinate pair, it tells us that. Now, Rahat did Pythagorean theorem to find the length of the hypotenuse. And if we do Pythagorean theorem here, this is a Pythagorean triple. So 3 squared plus 4 squared is 25. So the hypotenuse is 5. Steve, what's another Pythagorean triple? Do you remember? You and I talked about it the other day. 5, 12, and 13 is another one. So these are called Pythagorean triples just because they're quick. They work out to be whole numbers. 3, 4, 5 is the most common one. But 5, 12, and 13 also work. 144 plus 25 is 169. Square root of 169 is 13. Okay, there's your Pythagorean triple lesson for today. All right, you're like, okay, there's one more thing we're missing. What else do we know? Scale factor of 5. Perfect. Now you're mathing it. I just want to know one more thing about this blue triangle. There's a right angle. So the reason why we know this works, and they are similar, is because they share this angle, so it has to be the same. And they both have right angles. So if these 2 angles are, like, if they share this angle, that's the same. They share this angle, that's the same. That means this angle and this angle will also be the same. Now, we don't know what this angle is. It didn't tell us that. We don't need to know it. We just need to know that it's the same because it's shared in both of them. They have the 90 degree. Therefore, those 2 top ones have to be congruent. They have to be the same measurement. Okay? All right. You're like, still have no idea what you're doing. That's just building the triangle. I'm hoping that that will make sense to you guys. Now we're going to find the coordinates here. What do we know the coordinates are for a point on the unit circle? In trig ratios. Cos theta, sine theta. Cos is your x, and sine theta is your y. Now, somebody on the quiz the other day said, how am I supposed to know that? Well, we proved it in 4.1. I don't expect you to prove it every time. If you need to commit it to memory. Alphabetical order, cos first, sine next, x, y, alphabetical order, get it? So you need to know this. So all really we have to do is we just have to find the ratios of sine and cos of the big triangle. We're not going to talk about tan. Don't talk about tan. Wait till you get to the z plane. There's an x, there's a y, and then there's a z. And then all of a sudden you're doing linear matrices on 3 dimensions, 4 dimensions, and you want to cry a little. Getting everything to zeros and ones. It's welcome to linear algebra. Okay, so we're just going to do the ratios of these. Easy peasy. Rahat did the hard work. He found the hypotenuse. This, I'm going to switch to green. This is a key point. You need to be able to solve for your hypotenuse using Pythagorean theorem. You can't do this question unless you have that hypotenuse. Because we know, if I go back to blue, cos of the angle, I don't care what the angle is, because I just need it as a ratio. Remember in grade 11, you all wanted to solve for theta? You don't have to, you just want to work with that ratio. So remember that we're always measuring the angle from positive x terminating here. So our angle is going to be down here. So cos is adjacent over hypotenuse. So it's going to be 4/5. And sine of that triangle is going to be opposite over hypotenuse, which is 3/5. So what is the coordinate pair at p theta? There you go. Like I said, not hard math, but easy to get confused with all the math I expect you to remember how to do. So is this an exact value? Is this a value that we find on the unit circle that we have to memorize? No. There's lots of points on the unit circle. Just we're being really specific. We're doing 30s, 45s, and 60s. We're doing multiples of those, so this is a point in between there. Okay, this is going to be on your next quiz. There's going to be a question like this on your test. So emotionally get prepared. Can you do this? You can. It's the exact same. Do it anyway. What quadrant are you in, ladies and gentlemen?
Quadrant 2.
Quadrant 2. Guys, if you have a question like this, you do not have to prove that they are similar triangles. They will be similar triangles, I promise you. You don't always have to prove it. You don't always have to figure it out, but you do have to remember the other side of it. What?
That first
That says p theta.
that's 2 0.
That's p theta. P theta. Okay. Red triangle. Red triangle is where you have to do your work. The big triangle, the triangle outside the unit circle is where you have to do your work. What do we know the base of that triangle is? 3? Absolutely. We might say it's -3, and you wouldn't be wrong. Okay, what's the height of that triangle? 6. Okay, what's your next step? Hypotenuse. Get the hypotenuse. If we're doing lengths, it would just be 3. But when we put it into Pythagorean theorem, the -3 will square out. So, and what do we know hypotenuses are? Are they always positive or always negative? Always positive, because that squares are going to get rid of any negatives that we have. So I'm going to write -3 there just to remind myself that I'm in the second quadrant. Next step is going to be to do the hypotenuse. And we're going to leave it as a radical. We're not going to put it into a decimal.
Square root of 45.
Okay, and we're going to simplify that. We're going to simplify it. Okay, I'm not with you guys. So 6 squared is -3 squared equals c squared. So we have 36 plus 9 equals c squared. So 45 equals c squared. So c is equal to root 45. Let's simplify that 45. What are the factors? Pardon? 3 square root 5. So Steve, the factors of 45 that have a perfect square in them would be the 9 and the 9 and the 5.
Move this stuff.
You should, like, here's the thing, ladies and gentlemen, you need to be able to give your answer in the smallest possible form, and this is going to matter. Okay, so we know our hypotenuse is 3 root 5. Are you guys okay if I don't write it on my triangle just because it's going to get messy? Okay, well then you write it on your triangle. Okay, so now let's talk about our green triangle here. We just got to find sine and cos. Sine and cos. I'm going to do cos first. I'm going to do cos first because it's x and y, so I'm going to get in the habit of doing cos first just because it helps my brain. So cos is going to be -3 over 3 root 5.
Can you simplify that?
You can. What's it going to be?
A -1 over root 5?
Yep. So this is the benefit to putting a -3 here, is that when I do the adjacent side, if I put a +3, I might forget that I'm in quadrant 2, and my cos is going to be a negative answer. And then sine is going to be 6 over 3 root 5, 2 over root 5.
Just use simplify, right?
Yeah. And I've left myself no room. So P theta has a coordinate of -1 over root 5 and 2 over root 5. I would not rationalize my denominators unless the question specifically asks for it, just because I think that could get a little bit messy and you don't need to. But the expectation is that you see 45 and you're seeing that you can simplify this. And I know that's a bit of a stretch, but the idea is this is the most correct answer. If you have 45 inside this, like if you have 6 over root 45, you can still simplify it. So you're giving me an answer not in its simplest form. So we've got to get better at the details. You guys are like, I'm barely hanging on to the concepts. But if we can get better at the details, it's like writing an essay. You build on it, and then by the end, you're writing really great, well-constructed essays. Same with math. You're getting to the point where you know you need to leave it in simplest forms. You know your coordinate pairs need brackets around them. You know that you're not putting equal signs unless there's an equal sign in the equation, right? So that's what we're trying to do. We're trying to get to the best possible answer. Okay, makes sense? This is going to be on your quiz and your test and your exam. All right. So now we're going to work backwards. Okay. How to find a missing circular function. So what I mean by that is tan theta, cos theta, or sine theta. Just some basic trig ratios. When one of those is given, when one sine, cos, tan is given. Okay? Identify the quadrant, set up the triangle, solve for the missing side using Pythagoras, and then do your other ratios. It's as easy as that. It's actually quite easy, but this looks gross. This doesn't look fun or anything like that. Okay. This tells me my quadrant. Where are you?
Quadrant 1?
Quadrant 4. You're in quadrant 4. So theta has to be greater than 3 over 2, 3 pi over 2, or less than 2 pi. So really what you're looking for is these two.
What's the middle?
This theta, the angle is located in. the angle has to be greater than 3/2 pi. Exactly. It just means it's between those. That's a really good way to describe it, Steve. So we know that we are in quadrant 4. We know that tells us we're in quadrant 4. So we're looking for that to show us where we are. And then we're going to put this information on there. Where's my angle measured from? Always from the origin, right? Between the x-axis and your positive x-axis and your terminal arm. So there's your theta. Always between your terminal arm and your x-axis, never your y-axis. So we know that this point down here, well, we don't know what that point is yet. We know that sine is opposite over hypotenuse. So on this triangle, you guys told me that hypotenuse is always, always, always positive. And I would always 100% agree with you. So this is a positive 5. So what do we know about our opposite side? Has to be negative. It has to be the -3. Okay, we've drawn the triangle. So we need to find cos and tan. So we're missing a key piece of information. That x value, and we're just going to use Pythagorean theorem to solve for it. But this time we have the hypotenuse. So it's going to be -3 squared plus b squared equals 5 squared. So is b +4 or -4? How come? So we know in quadrant 4, our x values will be positive. So now that you have all 3 sides of the triangle, you can easily do what? It's just another Pythagorean. You did not have to show me this work if you identified that this was a Pythagorean triple and the answer was 4. You don't have to show me that. I'm showing you it in the notes just so that you know the process in which to do, just in case it's not a Pythagorean triple. So then we're going to go cos. Still don't know the angle, still don't care. Cos is going to be 4/5. And tan theta is going to be -3/4.
Is this entire year going to be about cos tan?
There's a lot of it. So 3 units, 4, 5, and 6 are all the trig stuff. We're going to do 4 and 5 together, then we're going to take a nice break, and then I'm going to come back and hit you across the face a couple times with chapter 6. Yeah, good times.
Ms. John, thanks for making our high school experience.
Okay, rotations on angles. Rotations on angles. Do you guys have your unit circle?
No.
Yes.
It's in your notes. Get it out. Get it out, you crazy kids. What? Why isn't it in your notes? Oh. Okay. If you don't have your unit circle in front of you, that's okay too. I'm not going to do the whole unit circle on the board, no. That's supposed to be a 0. Okay. Those are just the basic ones on the XY coordinate. If you have your unit circle in front of you, I don't know if I have a filled in one. I'm sure I do somewhere. But there's a relationship here. And every time you rotate your angle 90 degrees, so if we start here, what's my coordinate pair? 1 and 0. If I go 90 degrees, 0, 1. So there's something that happens between the coordinates every time you rotate 90 degrees. They switch. So when you rotate 90 degrees, the coordinates switch places. And if you look at 60, and 150, because that's a rotation, that's a 90-degree rotation, what happens? Okay, let's go through and do our unit circle. It's a good practice. I'll do it. So we know that this is 1, 0. This is pi over 4. What are the coordinates of pi over 4?
1 over
Root 2 over 2 and root 2 over 2.
Not 45.
There's 3 numbers you need to remember. 1/2, root 3 over 2, and root 2 over 2. Those are the 3, and then it'll be the order and the combination. These always go together. They're always a pair. It's root 2 over 2 and root 2 over 2. They don't separate. These two, you got to figure out what order they come in. So I'm not asking you to memorize 800 things. You have 3, and then you got to figure out what order they come in. So this one here is 30 degrees, and that's pi over 6 in radians. So this is where my short, long thing helps. I know that my x is longer. My x is longer than the triangle is tall. So I know that root 3 over 2, because that's a bigger decimal, is the x, and the y is going to be 1/2. And then this is 60 degrees, which is pi over 3. And I know that my triangle is taller now than it is long. So that means my x has to be 1/2, and my y has to be root 3 over 2. So really you have 3 numbers to memorize. Anything with a 4 on the bottom is going to be this one by itself. This is 90, so that's pi over 2. And that's 0 and 1. Okay, what's 90 plus 30?
120.
120. That's 120. What is it as a radian? It's a pi over 3. But it is how many pi's over 3? 2 pi over 3. And we know that that triangle is a mirror image of this one. It's just I'm in quadrant 2 now. So what do I know about this coordinate? I know that my x's have to be negative. So my x is short, my y is tall, so negative 1/2 and positive root 3 over 2. That's 135. So that is 3 pi root 4. And if it has a denominator of 4, it's just my root 2 over 2. But again, I'm in quadrant 2, so it's going to be a negative root 2 over 2. And then my last one here, if that has a denominator of 3, this has to have a denominator of 6. So that one's going to be 5 pi over 6. And I know my x is longer than my y is tall. So that's going to be a negative root 3 over 2 and 1/2. So that's a strategy that I use to go through. I do my tall, long. If I can draw my picture, that helps me remember. Okay, here we go. So we rotate from here 90 degrees, our x and y switch. If we go from 30 degrees, what's 30 plus 90?
120.
120. So where's 120? Is it here, here, or here? It's 2 pi over 3. What do you notice about the x and y coordinates? They switch. So every 90 that you travel, guess what happens to your x and y? They switch. You just have to figure out where you are to give it the positive, negative touch. Okay? Can you guys mouth out your unit circle yet?
No. Yes. You lying.
Okay, this, like, you guys have a quiz, I'm going to say Monday of next week, and you're not going to get a unit circle. Yep, but you're here Tuesday, Wednesday? Tuesday we don't have school.
Wednesday.
So why don't we want Tuesday?
It's a professional development day. All right. Guys, where are you on the unit circle? If your original point is a positive x and a positive y, where are you?
I agree.
You're in quadrant 1.
I agree.
Okay, so you're in quadrant 1. That's really important you know where you started. So if we are taking our theta and we're in quadrant 1, so you guys are saying we're in quadrant 1, and I subtract 90 degrees from it. What quadrant are you in now? 4. I don't know. We just started with it and I went. So we're in quadrant 4. We're going to rotate. We're going to subtract 90. So we're going to end up somewhere here. What do we know about the x and y in this quadrant? X is positive, y is negative. Pardon? Theta minus 1/2. So whatever the angle was, we don't need to know what the angle is. We just need to know we're taking 90 away from it. So we're not going in a counterclockwise direction, we're going in a clockwise direction. So we know in quadrant 4, our x is positive, our y is negative. So what is the coordinates of this point?
Negative 3 over 2. Negative. Negative 1.
Hey, one at a time.
It's negative.
All right, so all we did was flip-flop the x and y. We traveled 90 degrees, but we needed to add the appropriate positive negatives on it. And that was like question 9 from the quiz. You needed to add the appropriate positive negatives on it based on what the restriction was. In part A, there was no restriction. In part B, there was a really specific restriction. Okay, so you guys told me that we were in quadrant 1, so we're starting in quadrant 1. We are adding pi. So adding 180, but let's go in 90s. How many 90s are we adding?
290.
We're adding 2 90s. So if we go 90, where are we? Quadrant 2. And what happens? Now we're going to be in quadrant 3. So we know that this is in quadrant 3. What do we know about the coordinates in quadrant 3? Both are negative. Okay, you rotated 90. What happened to your x and y? They switched. You rotated another 90. What happens? They switched back. But this time they're negative. So we're going to have a negative 1/2 and a negative root 3 over 2. No math to do here, but some visualizing and knowing stuff about your coordinate plane. Okay. Not difficult, but it's hard to remember. Okay, this was the Claudius data chart. Do you guys know? Is this on your notes?
Yes.
In this place?
No.
Okay, so go back. Go back to 4-3. Go back to 4-3.
No, you can't use last to become
I know. You were missing. All right. Good reason, good reason.
More than that.
What? No, don't say that out loud. Don't say that out loud. Okay, this was a student of mine, Claudius. He taught me how he remembered it. I thought it was really great. So, like I said, I use the short longs. That's how I was taught and how I remember. This is how he was taught, or he found, because I taught him, and this is how he remembered. So it might be better for you. Pi over 6 is my smallest angle. Pi over 6 is my smallest angle, it's 30 degrees. Pi over 4, and then pi over 3. This one's helpful because it talks about tan. Okay, SOHCAHTOA, right? Sine, cosine, tan, that's the way we always say it and when we taught it in grade 10. Sine, cos, tan. Sine. 1, 2, 3. Cos. 3, 2, 1. What are the fractions that you need to remember? 1/2, root 3 over 2, and root 2 over 2. Oh, that's supposed to be a 2. So that's how Claudius remembered what went with what.
Which year did you teach?
Claudius, I taught his, did I teach his younger brother? Oh no, Claudius has been gone for a bit. Yep. Michael was his younger brother. But Claudius taught me this. Okay, so 1, 2, 3, 3, 2, 1, and then you just do the fractions on them. And that's how he taught me. Okay, tan. Tan of the smallest angle is the smallest fraction. Ooh. Okay, what's tan? Tan theta is sine theta divided by cos theta. So if we do that math, that's going to be 1/2 divided by root 3 over 2. So 1/2 times 2 over root 3 gives me 1 over root 3. Smallest angle, smallest fraction. What's root 2 over 2 divided by root 2 over 2? Without doing any math.
It's 1 and 1.
It's 1. Anything divided by itself is 1. Here for it. Okay, so if tan is sine over cos, if we're doing it for the largest angle, that's 60 degrees, then we're going to have root 3 over 2 divided by 1/2. So root 3 over 2 times 2 over 1. The biggest number. So this is nice because I really don't remember tan. I can map out tan, but this table's nice because it reminds me what order tan goes in. So if there's a denominator of 6, I know it's going to be the smallest. If there's a denominator of 4, it will be 1. And if it's a denominator of 3, it will be the biggest root 3. These principles stay true based on the denominators, not just first quadrant. They, if it has a denominator of 3, these are going to be your cos and tan and sine. They'll just be positive and negative based on where you are on the unit circle. Okay, that's it.